Hi, I'm here at CLEO 2016 with Dr. David Reitze, Executive Director of the LIGO Laboratory and the California Institute of Technology. Dr. Reitze, after a 40-year-long quest, the recent detection of gravitational waves have opened up a new wave in astronomy. Your plenary presentation described current research efforts of the LIGO project and how this research will move us to future discoveries in the universe. Can you tell us what's next for advanced LIGO?
Certainly. I think there are a couple of things. First, we are in a period right now where we're actually not observing. We're making our detectors more sensitive. So when we built these detectors, they were designed to operate at a certain sensitivity. In other words, a certain distance to which we would see binary black holes, for example. We're not there yet, and we knew we wouldn't be there in the first run. So we're pushing our detectors harder to get them to the point where we're at design sensitivity. That's going to take probably 2 or 3 more years, maybe even 4 more years, depending on how things go. So that's the near term. During that time, we will come back and do more observing runs. So we are going to start another observing run late this year, probably in August or September. That'll be a 6 or 8 month run, and then we'll go back and again improve our detectors a little bit more. So that's the near term. In the far term, we're actually thinking about how we can make our detectors even better than they were originally designed. And so we'll use techniques that were invented by people like Jeff Kimball and Dick Slusher, using squeezed light to be able to improve the sensitivity of our detectors. So that's something that's really exciting. That'll probably happen in about 5 or 6 years. So we've got a lot of plans for the future.
Attendees here at CLEO are naturally interested in the advanced optics inside LIGO interferometers. How will these optics inside the interferometers need to change in order to achieve future discoveries?
So the optics that we have in the current detectors in advanced LIGO right now will probably be pretty good for the next couple of years. We may make some changes because some of the mirrors are not quite coated properly. There are improvements that we can make to the coatings to make the interferometer a little more sensitive. That's something that we might do over the next 2 or 3 years. But overall, I think we've got pretty darn good optics. In fact, we worked very hard to get those optics. Where we're going to go next, even beyond advanced LIGO, is we're thinking about what's the next big detector you could do, and you want to make it even more sensitive than advanced LIGO. So instead of using fused silica optics, which is what we use in advanced LIGO, we might even use silicon optics. All right. So the challenge for us now is to get pieces of silicon that are that big, that weigh 100 kilograms. You have to polish it, you have to coat it, and then you have to make lasers that go through silicon because of the way our interferometers work. So we're looking at 1.5 and even longer wavelength lasers, high power lasers, stabilized lasers. So there's a big research effort that's ramping up to try and think about the next generation, and it will use silicon. The other interesting thing about it is we'll actually probably cool the mirrors. So we'll take the silicon mirrors and cool them down to not quite liquid nitrogen temperatures, but maybe 120 degrees C, and that will help reduce thermal noise, which is a noise source in our interferometers. So yeah, we have grand plans to really completely redo our interferometer, probably in 2025, 2026 timeframe.
Fascinating, thank you. There's been a lot of interest in this discovery from the science community, major news organizations, and even late night TV. What surprised you the most with how the world has reacted to the news?
I was, quite frankly, blown away with how much attention this got worldwide. Somebody in the laboratory, LIGO laboratory, did a survey, and it turned out we were on something like 250 daily newspapers the day after the announcement. As you saw in my talk, we've made it into popular culture. Gravitational waves are now fashion statements, as you can see here. So I think it was stunning how big this announcement was and how people took to it. And I can tell you from a personal standpoint that my life before the discovery announcement and after the discovery announcement is quite different. My time is much less part of my own self because I'm always giving interviews and doing talks and things like that. But that's a good thing.
Fantastic. Mm-hmm. Thank you, and we'll sign off here from CLEO 2016.